with the color with the red group, the RGB values, and I change those values, and you can see the color changes. Now let's do an Android beam of this laser device onto the other phone. And as you can see, the other device actually gets this. Now let me repeat that once again. Let me take Raisuke's help here with the mic and the phone. Thanks. So Raisuke is going to show you the phone screen, and this is my phone screen, and I'm going to change the color now. What I have is a slightly blue color. Now I'm going to just touch it in the back of this device. What do you see there?
I can see
Right? This is Android Beam. This is just color. We are just sharing a color code, but you can share photos, links, YouTube links, intents, and stuff. Anything, basically anything. So this is very innovative and a very nice technology. Zero setup. We didn't do anything. We just brought the device closer. That's all we did. Right. Thank you. Right. So the final section is the Android, the new camera APIs. What's new with the camera? The first and most important, and again very innovative thing, is the face detection API. So what it does, it basically it looks at your camera preview, the preview stream that is coming in, and it can detect human faces there. As a programmer, when you start a face detection, what you get back is you get a bounding box, which is a rectangle covering the face in the screen, and you get mouth and eye positions. So it basically helps you detect a face in the frame. Now what do you do with that face, right? What do you do with it? It's not face recognition, it's not basically telling you who that person is, but it just gives you, there's a face right there on the screen. So some more new APIs actually help you or showcase the power of face detection, which is custom focus zone. By this we mean tap to focus. You can actually tap a part of the screen and the camera sets that area that you actually tapped on as the focus point. So when you combine this with the first, which is the face detection, you can actually create amazing photographs and amazing camera applications. So when we have a frame in the screen, we detect a face and show the face overlay. The user actually taps on the face and the focus happens right there. Or this can be done automatically too, because you can set up the focus zone depending on the box you actually got. And the third thing, again very related, is the custom metering zone, which is if you have a scene which has higher dynamic range, which is some parts are dark and some parts are very bright, and you want your subject, which is actually probably in a darker part or in a very, very light part of the scene, to have properly focused light, you can set the custom metering zone to that particular area where you detected the face. Or this could be any other area in the scene. So basically you're telling the camera that meter the light of the entire frame on this particular area, which is a neutral area. So to make sure that the face is exposed properly and you can see the person's face, it's not too dark. So this is how you can build awesome camera applications yourself by using these three APIs. Now let's see how they work. So the first thing you do is, on your camera you call the get max num detected faces, which basically tells you the number of faces the camera can detect. If it's greater than 0, that means face detection is supported on the camera. If it returns you 0 or a negative number, that means face detection is not supported on this camera. So you make that call. That's the first call you should do. Once you find out that faces can be detected, you start face detection. You do a camera dot start face detection. At this point, the driver will start scanning the incoming stream from the preview and find faces. As soon as it finds the face on the screen, it will call on face detection, and your activity or your component or your class should be implementing this interface, face detection listener, to have the camera system call this method. So on your implementation of on-face detection, you would get an array of faces. Array of faces is basically the rectangle, the mouth, the left eye, and the right eye coordinates. At this point, you can choose to stop face detection, which is you found the faces on the frame, stop the face detection, and actually go ahead and click a photo or start a focus on that zone. So very simple, very easy. Now, let's say you got the faces in the previous frame. At this point, you will use one of these calls to find out whether your camera supports custom focus zones and max number of metering areas. So, does it support? How many metering areas does it support? Again, if the number is greater than 0, that means these technologies are supported on your camera and phone. So you begin by setting the face rectangle as the metering area, which requires a list of faces or a list of rectangles. So you can set that particular area as a custom focus zone. Your camera will be able to focus on the faces detected on the scene. There is some calculation there, because the camera coordinate system is -1000, +1000, 0, and +1000, and your screen coordinates may vary. So you'll have to do a translation based on the phone that it's running on. Again, you can actually find that stuff from by using some API calls to Android system. You can discover the coordinate system, the size of your preview frame, and do a matrix translation. So this will, when you actually do a set metering area or set focus area, this will actually trigger camera focus. You're not actually clicking a photo at this point of time, but the camera will go ahead and do a focus and balance the light of the scene based on the metering zone. So let's do a quick demo of the camera and see how this works. So I'm actually going to use the default camera app, but which actually implements these APIs, but you can do it in your own camera app. It's the same thing how it's going to work. So again, I need a guinea pig. Right, okay. So it's pretty dark here, so let's see if camera face actually is being detected. So you can see the screen, right? So you come here in the light, and probably difficult to see, but there is a rectangle which is tracking his face. There's actually a rectangle around his face that's tracking his face. Now, I'm going to do a tap and do a focus there. I'm going to tap and set the brightness of the screen according to that. You see the rectangle has turned green, which means the camera was able to focus on that region. Now to balance the light, or just to show you a demo of the light, I'm going to tap on a dark part of the screen, which is the probably Raisuke's shirt there, which is black. You see that overexposes the scene because I'm actually metering the light on the black. Underexposes it. So this is basically how face detection works, and the other APIs that go along with it, which is set custom focus zone. If you have multiple faces and your camera gives you a value which is get maximum number of supported faces, maybe 2 or 3, and then you have 3 faces in the screen, you can actually tap to focus on 3 of those faces. So yeah, so that basically wraps up this. Thanks again, Raisuke. So this basically wraps our 3 demos and 3 innovative technologies present in ICS that I was going to talk about, and ends my presentation here. Quick resources plus Android page for all Android related news @Android Dev is the Twitter handle. I'm on Google Plus again, plus Anirudh Devani, which is anirudh.devani. You can reach and meet your circles. And all our teams for our various products are listed in code.google.com/team, including all of us. So let's move to the questions. Any questions?
I want to ask, when you use the face detection API, how often will you get the face detected when you using the camera bound to the camera preview rate, or say every image, or just when you get a focus image?
So focus is something that follows after face detection. So once you detect the face, you tap for the focus. But the face detection is works pretty well, even on moving subjects. So if I have the camera and my subject is a human who is moving and the face is visible, the face detection is something which is live. So it actually tracks the face as it moves, and you can click there to focus. And again, with the zero shutter lamp on the phone, you can take an immediate photograph there. So, but it works pretty well. From what I have, my experience, it always works. It's able to detect faces. Did I get that right? Was that your question?
My question is, how often will you get the face detect array from the listener?
So that basically depends on when you call stop face detection. If you're not calling for stop face detection, it keeps immediately calling and you keep tracking, right? Because if the subject is moving, you want to redraw your rectangle, right? So it's immediate, and you can redraw your rectangle, move your rectangle on the frame to track the face, right? So it's immediate. You have to call stop face detection to actually stop that from happening. Right. Anything else? Anyone?
Hey, thank you. I want to ask you, how does the Wi-Fi Direct to discover the peers?
Okay, so it's basically when you enable Wi-Fi Direct, right? It's part of the Wi-Fi spec, direct spec. So the device that is available on the framework will broadcast itself. So the device is able to find other devices that are broadcasting itself, and once you do that, that's when the framework allows you to make a call to the Wi-Fi system, which is discover peers. At that point, the framework will talk to the Android runtime running on the other, using the Wi-Fi available there on the other device, and is able to get its MAC address. So basically, the device is broadcasting its MAC address. And once you find the MAC address and you actually do a connect, one of the devices becomes the access point. Basically, a network is created and that device is assigned to this access point. So at that point, the device becomes a client to the other device, and one of the device becomes the group owner. This is not visible to the user, it happens in the background, because the user, it's like a peer-to-peer connection technology. One of the devices assumes the role of a group owner, and that actually creates a network like 192.168.1.1, and the other devices connect to it, and that's how it goes. Any more questions? Okay, so I guess that's it. We can move to the next part of the day's agenda. Thank you, everyone.